This is Andy Taylor. I'm chair of the ACI 318 Building Code Committee, and I'd like to cover a topic today which has become very important in the last decade or so, and that is sustainability. And I'd like to address how sustainability is included in the ACI Building Code and the steps that we plan to take for implementing sustainability and sustainable design provisions in the 2025 edition of the ACI 318 code. Very briefly, I will discuss this topic in two major sections. First, I'll talk about the current provisions of the ACI 318 2019 code. This code contains a few provisions that support principles of sustainability, but then I will go on to discuss the work that we're currently doing to improve the sustainability provisions even further in the next edition of ACI 318, which will be published in 2025. Regarding the building code in general, I want to talk first about what the American Concrete Institute is doing now with regard to sustainability, not only in the ACI 318 code, but in other activities. I'd like to describe what difference the structural engineer, that is, you and I, can make in this realm of sustainable design. I'll talk about what new sustainability provisions have appeared in ACI 318-19, and then I'll talk about the future sustainability provisions that we're developing for ACI 318-25. First of all, here's what ACI is doing with regard to sustainability currently. I think we're all aware that concrete as a material has a fairly large carbon footprint. And anything we can do to reduce that carbon footprint is really key to reducing the effects of global warming. So ACI has published a number of reports and guides that address sustainability. There's more than 40 of those. ACI has also published journal articles, that is technical articles, more than 60 of those. ACI has also published more than 200 practice-oriented papers and articles. These are not formal technical papers, but offer guidance on sustainability practice in the day-to-day activities of structural engineers. We have over 100 learning opportunities, seminars, webinars, and so on online. And then we also participate very actively in sustainability events. So far, more than 25 of those. And during 2021 and 2022, we have a number of other events that we are going to be involved with, both as sponsors and co-sponsors. Now getting into a little more detail about one of the ACI technical committees, 130. I'm bringing this committee up because besides the work that we're doing in ACI 318, the Building Code Committee, this technical committee is focused exclusively on sustainable design provisions. The chair of that committee is Sean Monkman. This is a very large committee. It has over 100 members and includes 8 subcommittees, which each subcommittee is working on various focus topics. And I would draw your attention to a very informative overview of sustainability in concrete construction that was published by this committee in 2019. Report on the role of materials in sustainable construction. These are the subcommittees that are currently active in ACI Committee 130, materials, production and transportation and construction. All of those activities produce atmospheric carbon. Structures in service, rating systems for sustainability, and various tools for sustainable design. Design specifications, codes, and regulations. Here's where this committee interfaces with the ACI 318 Code Committee. Educational initiatives, climate change impacts on the sustainability of concrete, and a liaison subcommittee that interacts not only with other ACI committees, but committees in other organizations, particularly international committees. There's a new ACI Technical Committee, which was formed in the fall of 2020, ACI Committee 321, which is focused on concrete durability. Its objective is to develop a concrete durability design code. Now, why do I bring up durability in the context of sustainability? Clearly, if a structure made of concrete is more durable and lasts longer, then that's a more sustainable structure because it's using less resources over the total life of the structure. This committee is chaired by Professor Larry Sutter. There are 15 voting members, so this isn't as large a committee as the previous one I mentioned. However, they do have the objective of introducing a code on durability. This committee has only met twice so far, in the fall of 2020, spring of 2021, and it will meet again in the fall of this year. So let's shift to topics a little bit here and ask ourselves a philosophical question. What difference can the structural engineer make when it comes to improving the sustainability of concrete structures? So I can list a few things that we as structural engineers are not. We are not generally environmental scientists. That's not our training or background. We're not, generally speaking, regulators or government officials that deal with environmental regulations. We're not architects typically, although some structural engineers are also architects. And we're not the owners or the funders of projects. So we actually have a fairly narrow role in the execution of projects and in the way that they are funded and constructed. But we do have some influence on the sustainability of the concrete structures that we design. So here's a list of a few things that we can do. We can, as structural engineers, we can specify concrete mixtures that make use of alternative cementitious materials. Some alternative cements or cementitious materials produce considerably less carbon, atmospheric carbon, than the production of traditional Portland cement. And so these materials are evolving quickly. There's a spectrum of different possible cementitious material options that are coming available. And we on the ACI Code Committee are trying to keep up with all of these alternatives as they come out. But as engineers in practice, we might consider the use of these alternative materials for our designs. We can also specify in our structural specifications the possibility of using recycled concrete aggregates. It takes much less energy and there's much less carbon produced when aggregates are recycled rather than mined or quarried and perhaps crushed and then transported to the site. Another very simple thing that we can do is specify a time period longer than 28 days to achieve the required design strength. It's typically standard in our industry to specify concrete strength at an age of 28 days. However, if we have a more sustainable concrete mixture that we've specified, which perhaps has a slower rate of strength gain than Portland cement concrete, and we can accept that slower increase in strength, we might specify a time period of to achieve strength of 30 days, 45 days, even 60 days when it's possible. And that's a way to incorporate lower carbon impact materials in our structures. Something that goes without saying is we can design with minimum concrete volume. As structural engineers, we tend to make things, number one, we want to make things safe. And sometimes that leads us to create structural members that are slightly oversized. They aren't necessarily completely optimized for the strength required. And if we spend a little more time, we perhaps can minimize the volume of concrete required for a structure. Another way to minimize concrete volume is to use fewer repetitive members. For instance, we could reduce the size of columns over a tall building as the columns progress up the height of the building. We can use smaller columns. Very often we don't, because the contractor would like to use the same formwork over the entire height of the building. But given the impacts of concrete on the environment, it may be worthwhile for the contractor to spend a little extra time and effort creating reduced column sizes over the height of the building. That's just one example. We can also spend some of our time and effort promoting sustainability provisions in the structural building codes. And in fact, that's what I'm doing right now, is talking with you about how sustainability can be incorporated in our daily practice as structural engineers. So let's talk now about sustainability provisions in the ACI code. So until the 2014 edition of ACI 318, there was absolutely no mention of sustainable design. The code dealt entirely with strength and serviceability, but there were discussions about including sustainability in the code. So in ACI 318.14, we got a small start with section 4.9, titled Sustainability, which contained a very minimal introduction of sustainability as an idea or a concept. It was more of a bookmark. So it was a start to this process. And this section permits or allows, but does not require, the engineer to consider sustainability in design. So this gives the engineer the latitude to incorporate sustainability concepts into a project, but does not require them, at least at this point. That section also states that considerations of strength, serviceability, and durability have to take precedence or take priority over sustainability considerations. So here is the section 4.9. I won't read it word for word, but it's very simple, and it simply raises the issue or the topic of sustainability and creates a place where we can introduce more sustainability provisions. So then if we talk about ACI 318.19, we introduced some other provisions in addition to section 4.9. Chapter 26 contains provisions related to construction. And this, there is a section there now that allows, within limits, the use of what I mentioned earlier, alternative cements or alternative cementitious materials. So we now state explicitly in the code that you can use some cementitious materials other than Portland cement. But these alternative cements are only permitted if they're approved by the licensed design professional, that is us, the structural engineers, and by the building official. So there is some requirement for obtaining approval to use these alternative materials. But given the urgency of improving the environmental impacts of concrete construction, we think that it should be possible to obtain these sorts of approvals in most jurisdictions where sustainability and reduction of atmospheric carbon is a priority for many government authorities that are issuing building permits. This approval that you would obtain for using alternative cementitious materials should be based on test data that documents the proposed concrete mixture made with this alternative cementitious material meets the performance requirements for obviously strength, but also fire and durability. We need our concrete structures to be durable, especially when they're exposed to weather and other environmental conditions. Now in 2019, the 2019 version of ACI 318, the use of recycled aggregate is encouraged. The definition of recycled materials in the Materials Standard American Society of Testing and Materials C33 is quite broad when it comes to aggregates. And the engineer is cautioned in this commentary section here, that's shown here, to examine these recycled aggregates closely and make sure that they are compatible with the design requirements, because ASTM C33 may permit those aggregates, but the engineer may know of other reasons why their use might be restricted to certain elements, such as slabs versus beams, or other restrictions on their use that I can't really cite any specifics, but the engineer should be aware that not all recycled aggregates are suitable for all applications. Again, if you want to use recycled aggregate, you need the permission of the licensed design professional, that's us, and the building official, based on certain documentation. And this documentation is described here. You must demonstrate that the concrete that uses these recycled aggregates has the necessary mechanical properties and durability properties required in the structure. And a testing program to verify the aggregate consistency to achieve consistency of the finished concrete product is conducted, and this is important, throughout the duration of the project. It's possible that if you specify a source of recycled aggregate on a project, that there might be some variability in the stockpile of that recycled aggregate, especially if the aggregate came from different structures that were recycled. So you have to monitor the quality of the aggregate throughout the duration of the project, and that's explicitly stated here. So what's the future of sustainability in ACI 318? We are currently working on the 2025 edition of ACI 318. We're about halfway through the process of producing that code. We have until about the end of 2024 to actually complete the final version, so it can be published in 2025. We've created a new subcommittee, N, titled Sustainability. That was established at the beginning of this code cycle in 2019. The chair of that committee is Shana Kelly, who's a structural engineer, who is also an expert in sustainability issues related specifically to concrete construction. So we're very fortunate to have Shana chairing that committee. She has assembled a committee of 12 voting members, and within that committee, they have formed 6 task groups. So this committee has been meeting since 2019. And what are they doing? Well, their main objective is to write a new appendix for the building code, Appendix N. It will probably have a different letter by the time the code is actually published. But the purpose of this appendix will be to add sustainability provisions to the code in an appendix so that they can be followed whenever sustainable design practices are required for a project. So what we're doing is not creating mandatory sustainability requirements in ACI 318, but we are creating sustainability provisions that can be invoked or used if a project has a certain sustainability goal. These will be available in the code for optional use. So that's the purpose of Appendix N. So I mentioned also that Subcommittee N has 6 task groups. 4 of these are related to technical content, doing research, writing, gathering information, and assembling a consensus of opinion on sustainability provisions that will go into this appendix. 2 of the task groups are looking at the provisions that currently exist in ACI 318.19 that I discussed a few minutes ago. And they're looking at the current alternative cements provisions and the current recycled aggregate provisions to coordinate them with Subcommittee A. Subcommittee A is the subcommittee that deals with concrete materials. And we want to have good coordination between Subcommittee A and this new Subcommittee N. So that's what those other 2 task groups are working on. So here's the scope of Appendix N that will be in ACI 318.25. First, an outline of what's in the appendix, then sustainability measurement metrics. So if you're going to create a sustainable structure, you need to have ways of measuring its relative sustainability compared to other structures or other types of materials. And so that's what this section specifies. The overall sustainable impacts of the structural system. So this is as distinct from the concrete as a material. This is the concrete as a structure. And things like thermal mass come into play in this under this topic. And so that's what that section will deal with. And then finally, I mentioned the topic earlier of durability. Also resiliency is sometimes a word that's used in that context. A resilient structure will resist all the attacks on it from earthquakes, gravity loads, weather, and so on. And it will have a expected lifetime, which would be perhaps longer than a more conventional structure. So how does this resiliency idea interface with the idea of sustainability? So if you'd like to find out more about sustainability in ACI 318.25 and more about sustainability of concrete structures in general, I suggest that you consult some of these resources. There is the ACI 318 code. I've just described to you what's already in the code and what we're planning to add to the code. I mentioned at the very beginning of this presentation the ACI 130 activities, including their 2019 report, which I think is a great place to start in trying to understand sustainability, and both from the point of view of concrete as a material and concrete as a structure. ACI 201 is also concerned with sustainability, and ACI 321 is addressing durability. As I mentioned also earlier, there are many publications, practice-oriented papers and articles that you can find through the ACI website. There's the ACI Structural Journal. The Materials Journal is very important in this regard. And then there are many ACI seminars and conferences like this one. We also have the ACI convention every 6 months in various locations, typically in North America somewhere. The next convention will be in October in Atlanta, Georgia. So I'd like to finish off with a very important statistic. This is what I keep in mind when I want to remind myself of how important this topic is. Way back 5 years ago in 2016, a study of global carbon distribution, or the producers of global carbon, atmospheric carbon, that in that study it was estimated that the cement production industry alone counts for 5.6%, and there's actually some authorities push that number a little higher, of human-made anthropogenic or human-made CO2 released globally. So if we think about it, we are responsible, structural engineers, for specifying and designing a material which is responsible for about 1/20th or more of the atmospheric carbon produced. If we as structural engineers, and we're a bunch of smart people, can reduce that by even a small amount, we're going to have a significant impact on global warming. So this is the purpose in me speaking with you today, is to raise your awareness of this topic, to let you know what ACI is doing in this regard, and to perhaps get you thinking about this area in your daily design practice. So that's all I have. Thank you for listening. Of course, ACI's website address is given here. You can always look there for more information. And that's all I have on this topic currently, and I'd be happy to take any questions.
Thank you so much for this presentation, Andrew. Hello, everyone. This is Manali from the Big Five team. Hope you enjoyed the presentation. We will now move on to our Q&A session. Andrew, we have received some interesting questions from the audience for you. The first one is, does this ACI 318 building code evaluate existing concrete buildings prior to repair?
Thank you. That's a very good question. There is a separate code for the evaluation and repair of buildings, which is ACI 562. That code is also used in conjunction with some other codes. There's ACI 369 for seismic considerations, and there's also ASCE, American Society of Civil Engineers 41, which is a code for evaluation of existing buildings for seismic considerations.
Okay. You covered the difference between future 31825 building code and the current 318 building code. What are the aspects that ACI investigate when forming such building codes?
That's a very interesting question. When ACI writes a building code, we follow a very rigorous process of what's called a consensus standard process where we try to create a code that is in agreement with the majority of opinions from engineers and researchers and building officials. It's a complicated process, but a very good one in my view, where we solicit or ask for the opinions of everyone involved. The ACI Building Code Committee has 50 members, 50 members. Then there are subcommittees on various topics, which brings the total number of people to about 150. So there are quite a large number of people involved in the code. With regard to Subcommittee N, which deals with sustainability, that is a subcommittee of about 12 people, and they come from both industry, construction industry, the engineering sector, and also material supplier sector.
All right. What are the top 3 takeaways that a structural engineer would need to convince building officials to use more sustainable practices when it comes to concrete?
Okay. Generally, when a project is focused on a sustainable practice, so I'm talking about the project itself, not the building officials, the project will set certain goals for sustainability. Typically, those goals are not really controversial or require too much convincing of the building official, unless the building official needs to approve some sort of alternative material. In that case, I think the best approach to convincing a building official to accept sustainable design practices is to point out that, number one, the introduction of the sustainable goals to demonstrate that those have no effect on the structural performance of the building, number one. Number two is to demonstrate to the building official the significant effect that concrete, at least Portland cement concrete, as a building material has on the environment. And some of those statistics are available through the ACI 130 report that I mentioned earlier. And finally, there's a process of education sometimes that has to happen, meaning a building official may be unfamiliar with sustainable design practices and therefore be concerned that those will somehow affect the function or longevity or structural integrity of the building. And I think the structural engineer needs to be sure to take time to answer questions, perhaps even proactively make presentations or provide additional information to the building official so that they're comfortable with the approach that the project is taking to promote sustainability.
Thank you. And what do you think is the main challenge for the concrete industry today and in the future, particularly on environmental consciousness?
Well, I think the biggest challenge is sustainability for the construction industry as it relates to concrete construction. At least in the United States, we see a rapidly increasing sensitivity and desire to improve the sustainable design practices for all types of structures. And we know that particularly cement production is a very carbon producing activity. So our biggest current challenge is to rapidly adopt sustainable design practices and materials. And the big challenge there is that new materials are emerging and new materials are being made available. And our biggest challenge is to quickly understand the acceptability of those materials and their performance. In the future, so that is our current challenge, is to try to grasp the size of the issue that we have and address it quickly. In the future, I think the biggest challenge to sustainable design practice may not be on the technical side. It may be on the financial side, where we find that certain sustainable design practices for all materials, not just concrete, may be somewhat more expensive than non-sustainable practices. And there will be a conflict between the goals of the owner, who wants to spend as little money as possible, and the goals of the rest of society, which wants to improve the sustainable design practices. I don't mean to say that owners are not concerned with economy, but there are some owners that are very concerned with the financial side, and less concerned with the environmental impact. So it's convincing those owners to pay a little more for construction for the good of the environment.
Thank you. And we have a last question here. Is sustainable concrete more durable, and what is its impact on the project's life cycle?
That is also a very good question. The durability properties of sustainable concrete depend on the materials that are used. And I should say that ACI is addressing the sustainability aspects of design very directly through formation of a new committee that I mentioned, ACI 321, on durability. I can't say whether all sustainable concrete design practices are more durable than less sustainable design practices. It all depends on the particular material and the particular practice. But I think that durability is possibly more related to the detailing and understanding the environment that may be leading to a shorter design life, such as a corrosive environment, and using both materials and construction detailing practices that address durability. So there's not a single broad answer to that question, but they are related. Durability is important to sustainability because, of course, the longer the life of a building, the more sustainable that is, because you aren't having to replace the building in a short period of time. You have a longer period of time, and that, of course, has less impact on the environment.
Perfect. Thanks, Andrew, for a great session. I think we've covered everything here. Thank you all for joining us today. We look forward to seeing you at the Big Five live in person at the Dubai World Trade Center in September from 12th to 15th. Stay safe and goodbye.